welcome to the Controller Talk podcast presented by Danfoss North America. Our goal is to bring you information about using Danfoss controls in the supermarket and warehouse industry, specifically in the U.S. and Canada. We're doing these twice a month for now. You can catch these podcasts wherever you get your podcast, and it's also available through the Danfoss Ref Tools app. For the video version, check us out on the Danfoss North America YouTube page. Search for Controller Talk to see our video collection. I'm Dave Yoder, along with Chris Brown. So Chris, here we are, football season. Ravens are doing well.
Playoffs right around the corner here.
Yeah, playoffs. They're playing the Steelers. Well, they should be
a little worried.
Guys.
Hope so, but always a little worried when that matchup happens.
Okay, Eagles are playing the Packers soon.
Yep.
My daughter likes the Eagles. She likes the Packers, but she's worried.
I think the Eagles take that one too myself.
I would agree. Yeah, you got it. And then we have, for some of us, we have college football to talk about. Penn State's still in it. Maryland faded long ago, but we won't talk about that. Yeah, so we'll see how far they can go. It's going to get tough from now on out.
It was some good games, though.
Yeah.
Last round.
Yep.
Looking forward to watching some of that, too.
That's right. Yeah, so we'll see how it goes. They can't have any home games right now because they're starting to tear apart the stadium.
Where do they play? Where is this game at?
It is in Miami for the Orange Bowl.
It's Miami, okay.
Yeah. Check your local listings. All right. Yeah, hey, I may have told you this before, but I almost had a psychic girlfriend in high school.
Lay it on me. Let me hear it.
Yeah. She left before we met, though. That's courtesy of one of my favorites, Stephen Wright.
There's a Manti Te'o joke in there somewhere with you, Notre Dame coming up for you, but we'll leave that one alone.
Yeah, start working on that for the next podcast. All right. So this is a podcast by listener request. I'll do a shout out to my man Eddie in Southern California. He works for CoolSys. That he said, you guys ought to talk about heat reclaim on these CO2 projects because the functionality is there and there's options there, but it's typically in the pack controller.
Yeah.
And it's not something that a lot of people know a lot about. And, typically when I'm on these jobs, our job one is to get the rack running and heat reclaim comes later. But yeah, we thought we would go through a bunch of different options and talk about some of the things that happen in the pack controller and what some of the options are. So, we're going to get into it right away. So, typically with CO2, there are heat reclaim options and concerns and requirements and stuff like that. So
each OEM wants to do it a little differently to some degree, so we've always got to have that in mind. That's a driving factor on how we set it up versus what our controllers got in there.
Yep. Some of them have their own theories and ideas about how to do it.
Mm-hmm.
Of course, it can be air heat reclaim or water or whatever, but
right, direct, glycol loop, it could be a lot of variables in play with all that for sure.
We used to think that people would stay away from direct CO2 into a heat exchanger or a heat reclaim coil just because they didn't want to get a leak and have the customers pass out, but I think those fears are behind us.
Yeah.
So in the pack controller, you'll see some of these are going to be set up under general purpose. So when you're in the pack controller, you're in service tool, you go into configuration, and you go into general purpose. And sometimes you'll see the heat reclaim option set up in there. And a lot of times that is done when you need an enable input, and then you control a variable actuator with a three-way valve. And that can be used for circulating glycol through the rooftop units and could be sending glycol out through a heat reclaim coil, or you may not even have glycol going out through that heat reclaim coil.
Yep.
So that's one way you'll see it done. And a lot of times that enable input is going to come from the HVAC controller. So it's a relay on the HVAC controller. It's a digital input on the pack controller.
Right.
And then typically you'll have a VO point because it's variable. There's a variable output coming off the pack controller. And a lot of times it's based on differential pressure between the discharge pressure of the rack, what we call PC, and an extra pressure transducer that's added to give us the gas cooler inlet pressure.
And that's usually why you find it in this section, is because some of the OEMs like or want that type of logic to drive it, but we just don't offer that in our normal heat reclaim section. So
there you go. Yeah, and I think you told me that we use these two transducers, and we're looking at a pressure differential, and a lot of times they look for a 1 bar or 15-pound.
it's pretty standard from what I've seen on the stores we've gotten involved in. Yeah, right around there.
Does that mean that typically the discharge pressure is going to be higher than the gas cooler inlet pressure?
Yeah, you want to make sure you're flowing in that direction across the coil out to the gas cooler. So that's how you make sure of that. Yep.
It's kind of what pressure differential means, doesn't it? Okay, so digging around in the service tool software of the pack controller and looking at general purpose, there is an option in there called Show Advanced Settings. Mm-hmm. And if you turn that on, you get some pretty decent options that allows you to control that variable output in the way you want them. Such as you can do a minimum opening. So you don't open the valve. So the minimum opening might be 10%.
Yeah. You never fully close the thing.
Right. Yep. And then the maximum opening might be 90%, because I've had some field guys from the OEM say, we don't want to try to shove 100% of the discharge gas through the heat reclaim coil.
Yeah.
We always want some going through the gas cooler. So you can do a max opening, so you always get some flow through the gas cooler.
Yep.
And then in addition to that, if you want, you can do basically a different sort of output when you're in startup. Like you came out of a power fail, you just started the pack controller, that sort of thing. You can set that startup time in seconds, and then you can say during this time period, I can do a startup output of a certain fixed percentage. And then if you shut the pack controller down or lose power, then you can do, you would have to shut the pack controller down while it still has power. Mm-hmm. And then you can tell it that when I'm in shutdown, I want to go to a fixed percentage other than 0 if you want to.
You should have it. You think you'll have PID settings in here too, if you wanted them to say how quicker, if the thing's slamming open as soon as you go into reclaim.
Right.
And you can always dial that back a little bit.
Most of those, they like them to be gradual.
Yeah. Yep.
And I believe it seems to be pretty gradual from the default settings in the pack controller.
A lot of times it's a Belimo or something like that, which is a slow actuator. Yeah, it's not moving too fast anyway, so even if you were to give it a 10-volt signal right away, it's not necessarily going to open up.
Right.
Within 5 seconds, it might be a minute or two before it actually gets to that position.
Yep.
A lot of customers, like you said, that use that general purpose section, but then we do still have some that it makes the most sense to take advantage of what we have canned in our heat reclaim section of the pack controller too. So whether this is water reclaim or air reclaim or both, you do also have the option, and you may see some stores set up where if you go under plant type, that's where you kind of initially configure a lot of your different portions of the rack, and compressors, gas cooler, etc. But it's also where you can say whether you have water, air, or both for your reclaim if you want to use the standard reclaim section that we offer. So you go into plant type, you either are setting that, or if it's a setup that's already been made, you're going to see that setting there. And then once that's enabled, then in your main configuration menu, you'd be able to see the option a little further down the list for heat circuits. Mm-hmm. And that's the section you want to get into from Service Tool if you want to see some more of your setup related, if it's being used again, but more of your setup related to those two types of reclaim. There's definitely some caveats, some requirements if you're using this, and this is maybe a reason sometimes that people may gravitate more towards general purpose. If you're using these options, let's just start with water reclaim. As soon as you enable that or say I've got water reclaim for this section, it's going to require you, the pack controller being it, but it's going to require a couple different temp sensors. At a minimum, it's 3 it needs to see in there, so it needs to see 1 temp sensor on the CO2 line after the reclaim circuit, usually designated as a STW2. And then you've got 2 sensors. It's assuming that there's a glycol loop in there They're called STW3 and 4. They're normally your return and discharge, return and supply. I guess I'll use the right terminology for glycol. But that's usually your return and supply temps for your water side on the glycol loop. The system needs to see those, or else it's going to kick out an air, excuse me, and it won't allow the valve to open up for reclaim. So you definitely, if you're using this section, you definitely want to make sure you're accounting for that, and you've got these sensors wired up, or else it just won't run properly.
Yeah, you'd have to look in, one option is to look in board and points if you're not sure. Now, a lot of times this stuff gets wired at the OEM's factory and it comes in already done, but
Yeah.
if you start seeing some sensor inputs that have no point assigned, and you know they're for heat reclaim, then you're going to have to take care of that.
Yeah, because that's happened in the past where the OEM just didn't install them. They said it'll happen in the field or something, and then it gets lost in translation and people
Yep.
forget about it.
Yep.
Those sensors, one of them can be used, and it would be that STW4 typically, your return. That's the one that we normally designate for control.
Okay.
The others are in place as safety. So if any of these sensors hit, you start to get close to boiling point, so it's around 204 degrees, you're going to get an alarm, and it's going to shut down your reclaim circuit. So it's going to close that valve off.
That's that boiling point error or boiling point alarm?
Yeah, we get that fairly often. Guys ask, what's it mean? Why isn't my reclaim working? And that's it. Once one of those sensors crosses that threshold, it's closing down the reclaim system.
So at 204, it closes it down, and then...
It's got to get pretty low before it'll allow it to run again. I think it's somewhere down around 160.
Okay.
And so if you're sitting there at 170, like, why isn't this working? It may have crossed that 204 and just not dropped down low enough.
Gotcha.
The other part of this is if you're using this section to control the three-way valve, we enable a pump. It's actually a pump signal that you see enabled. So we actually think we're sending a signal to a pump, where in reality it's that three-way valve.
Yeah.
So that's a little terminology thing guys might need to pay attention to, is if they see pump speed, that's actually a reflection of the opening degree of the three-way valve going to the reclaim heat exchanger.
So the original design intention was speed of a variable pump, but we use that signal to drive the valve itself.
Exactly. Yep. Similar with the air reclaim. So air reclaim would need the same type of sensors. They're designated as SHR instead of STW, but same purpose. One after the reclaim coil, and then you'd have them on the supply and return sides as well.
So if you see TW, you know it's set up for tap water. If it's set up for sensors with HR as part of the name,
Yep.
that's heat reclaim. But you could have both.
Yep, you can have both. It's two separate pages in the setup. So if you're in that heat circuit section, you just think water is the first one you'll see, and then you can just page over to your reclaim. But you see your set point there for when we want to start the circuit. This does also require an enable signal, just like the general purpose would.
Okay.
So we need to make sure we've got a DI wired in for these to enable control as well. Just surpassing that temperature wouldn't be enough.
Gotcha. And you have not seen a hot water heater for CO2 that doesn't use glycol yet, have you?
No,
Designs
I
coming
haven't.
through for that?
Not
yet?
that I'm aware of.
Okay.
I've heard of the direct coils in the rooftop units, but I have not heard or seen anything on the water side.
Okay. So then there is some built-in logic in the pack controller, and some of that base logic allows for the reclaim to function, but there's with that first option, there's no adjustments to the rack. Like, we're not going to adjust the high side pressure if we are in heat reclaim. Then there is another option that does allow you to offset the gas cooler pressure target.
Yep.
If you're in heat reclaim,
Right.
which makes sense, depending on what part of the country you might be in. And then there is the last option allows you to shift between a pressure target, where you shift the pressure target, you decrease the fan speed on the gas cooler, and then the gas cooler can go, it can be bypassed.
Yeah.
If you've got the valve.
If you've got that valve, yeah. So this would be in addition to the heat reclaim valve. We're starting to see some designs that have a bypass of the gas cooler altogether. And that
Right.
has some functionality for low ambient, but it's also used or can be used if heat reclaim. If somebody wants the absolute max heat reclaim they could get out of a system safely, bypassing that gas cooler is one way to give it to them.
We have a name for that valve, don't we?
V3 GC?
That sounds right. Yeah. I'm not trying to stump you. Yeah.
I was going to ask if that counts.
Not at all.
Can
Sorry.
it count?
We might need it later.
Yeah.
V3 GC
Yeah.
would be the valve that bypasses the gas cooler.
And that one is set up under the condenser fan section.
Okay.
So you'd be looking there for that. If it's going to exist, you'd either be looking for it there or under the just IO addresses. You'd notice it there too.
Could you have that with or without ejectors?
Definitely.
Okay.
Definitely.
Okay.
Because it's just it's used to try to prevent, for low ambient, you're trying to make sure that you don't get too cold
Yeah.
with that drop leg temperature.
Yeah.
And so bypassing the gas cooler gives you that. That doesn't have any effect on the ejector being there or not being there, though.
So if you are shifting your gas cooler pressure target, or if you're bypassing the gas cooler, then they require this thing we call a heat consumer signal, which is a 0 to 10 volt coming in that essentially says this is how much heat we need.
Yep. And so you cross I think there's a nice chart in the pack controller user guide that spells it all out, but something like from 2.5 volts up through 6 volts is where you're just offsetting your head pressure target. And then once you get 6 volts up, you're starting to reduce your fan speed. And then once you hit 9.5 volts is where, if you had the bypass valve on the gas cooler, you'd start to open that up.
So that's kind of driving the algorithm.
Mm-hmm. And people get a little confused because they say, well, I want to do all these things. And we say, okay, we need you to give us a 0 to 10 signal to tell us how extreme to get with where we're going to give you the most reclaim. And they say, well, I don't know.
And they say, where do I get that from?
Yeah, and so then it becomes a discussion point with, we could generate that in the pack controller. It could come from anywhere, really.
System manager.
Yep, and it could come from something outside of Danfoss altogether if they really wanted it to and had a good reason behind it. But that's an important part of this, is you want to have a signal being sent to the pack controller that's not overreacting, because you could be pretty quickly going from one extreme to the other, and that could have a pretty big effect on how good or bad the rack's controlling.
Excuse me. Cut that part. So could that in the simplest form, could that 0 to 10 volt signal be coming from the system manager based on a temperature sensor given a range, and then basically a range of set point, and then a variable output signal that comes over to the pack controller?
Yeah, or even with just the general purpose section of the pack controller could generate it too. If we want to look at one of the existing sensors that's already part of the reclaim.
Okay, just keep it all internal.
Yeah, because that would give you some flexibility too to reuse sensors. And general purpose, you've got PID that could maybe slow down how quickly we're adjusting the 0 to 10.
That's the difference, is the pack controller would give you the option to slow it down if you wanted to. Mm-hmm. It'll give you more options than you would have coming out of a system.
Which is just going to be a linear signal and might ramp up and down pretty darn quick.
Right. Okay. All right. And I hear that there's some more enhancements coming this year for the pack controller.
No, nothing concrete timeline yet, but we're hoping at some point here, that we see the some of this pressure differential control in particular being part of the canned options. So that'll be nice. It takes a little bit of the work and maybe a little bit of misunderstanding sometimes on where the people should be looking for the control of get it out of general purpose and put it under the heat reclaim section, and it's a little more straightforward.
Right. So it's pretty clear what's going on there.
Right.
Okay, gotcha. Okay. So I think that's a pretty good overview of what's happening with heat reclaim in the pack controller, so that they kind of can look at it and see what's going on at least.
And it's popular. More racks than not are going to have this on there, so it's definitely relevant.
Makes
You're
sense.
Talking about CO2.
Yeah, a lot of heat to be captured there.
People don't want to waste it.
Right. Okay. Well, Chris, we tried to stump you earlier with the V3GC question, but the real question is coming now. So Yeah, you were talking about the heat reclaim pump being an option in there.
Yeah.
And if you wanted to use it as a real pump, you know, there's I think there's an option that says that you can use the exerciser.
Oh, crap.
Excellent. So yeah, there's an exerciser option in there because the thought is that you want it to run every so often so that you don't create problems with rust or whatever in there.
Yeah.
You gotta keep things moving. So if you did use it as an exerciser, so it runs if heat reclaim's not used for 24 hours.
Okay.
So how long does it run, and what speed?
Let's just get this over with. Let's go. 10 minutes at 20%.
No, it's actually not that long.
No.
Now, neither one of us are going to remember this after this recording, but it's 30 seconds at minimum speed.
Okay.
Yeah. So.
If minimum speed's 20%, I got half of it, right?
Well, yeah, I'll give you that. But the main thing is I stumped you, so that's what everyone's waiting for.
2025 is off to a great start.
It is for me. Actually, that's all that matters. As far as listener mail, well, this episode was essentially inspired by listener mail from Eddie out in Los Angeles. Yeah, so there you go. If you'd like to drop us an email with a suggestion for topics to cover, or a question or a comment, you can call me if you have my number, but you can also email us at ControllerTalkNorthAmerica@danfoss.com. Thanks for listening. I would say our audio engineer is Raul Garcia, but I don't think he's going to do this one. Maria's not here. Josh isn't here. So we've relied on our old standby, Michael.
We're not doing this one ourselves.
No, Michael's making it all happen. He's going to do it all and remember. So
the listeners and viewers have never seen any of these people, so we could really just be throwing out random names and they would not know any better.
We could tell them your brother Charlie Brown is doing all the work. And for all they know. That's right. These people do exist, though. If it wasn't for them, yeah.
We'd just be talking to ourselves.
Pretty much. All righty. So thanks for listening. Until next time, for Chris Brown, I'm Dave Yoder. Stay cool.